Okay, I think we're ready to start now. So we cover, this is a fairly short chapter. Chapter 2 is a fairly short chapter, but remember that one of the aspects in the procedures for statistics was you had to collect the data and then you had to display the data. So what we focus on in chapter 2 are two types of ways for us to display or organize our data. Now, you'll see that as we move through the semester, we tend to separate both our qualitative and our quantitative variables. We'll handle them, we'll separate them out, I guess I should say. Or one day we'll do something with our qualitative variable, and the next day we'll do something with our quantitative variable. Because even though we're still going to talk about how to display those two types of variables, we display them in different ways, okay? So today's lesson focuses on qualitative variables, which we've already said are those types of variables that can be put into categories, right? So when we want to talk about displaying and organizing that data, we're going to talk about that doing it in two ways. We can do it using tables and we can do it using graphs, okay? What we get into in chapter 3 is the numerical summary. So summarizing it numerically. So you want to think things like mean, median, and mode, the average of something. That's what chapter 3 is about. So today we focus specifically on the tables and the graphical displays of qualitative variables. Now, the other thing you want to understand here is we have this term called raw data. StatCrunch just calls it data. We call it typically raw data. All right, raw data would be just a list of the data that you collected and you haven't done a single thing to it. Okay? All right. Now, what I want you to do is I have here the information for our impromptu survey, right? We did this in the class survey, but here we're going to work with it individually. All right. And so I asked you all to record for me the eye color, your eye color. And right now I would like for you, and by the way, this list of results that you see up here, this would be what we call raw data. It's just the data. We haven't done anything with it right now, have we? It's just sitting up here waiting for us to do something. So what I'd like for you all to do is I would like for you to come up with a table that summarizes the eye colors right here. Okay, I want you to create a table for me and tell me summarize the data that we've got right there. About 2 or 3 minutes, maybe 5 minutes to get that done. Okay, intuitively, what do you think you would do? What's your gut telling you to do? How would you display? How would you organize that into a table?
Probably eye color.
Yeah.
Uh-huh.
So I want y'all to just do it intuitively, then we're going to talk about it, all right? You're good, you're good. All right, so I want everybody doing that. And then we'll go over that. Yeah, I get mad at you for not talking, and then I get mad at you for talking. Sorry. Okay, so you can do this on your paper, or you can do it in the blank spot I left for you on your notes. Either one, I don't really care. We're just coming up with a table here. Okay, we're making a table here. You done? Yes?
No.
No? Okay. All right. I think we're pretty close here. Okay. So how do you go about creating a table like this? That is not rhetorical this time. I do want some input. What did you do to create your table, to organize this?
On the left side, I did like the amounts. Like I counted by twos. I did 2 to 12.
Okay. So maybe I should put in there each one of the colors that's available. Okay. Okay. So if I have eye color here. Okay. And I have, let's see, brown, blue, gray, green, and hazel. Those are the possible choices, right, that I would have for the eye color. And then if I wanted to know how many browns were there?
12.
There's 12, okay. How about blue?
2,
Gray,
1,
green,
0,
hazel.
2.
All right. So what is this column right here? It's the quantity, right? It is called specifically a frequency distribution. A frequency distribution, meaning you are going to take the frequency with which each of those categories occurred, okay? So the frequency distribution is just the count of how many you had of each of those categories, okay? Perfect, all right, and that's typically what you would have done in all of these, like, you know, one of the basic examples that we give to students is you get a bag of M&Ms, right? You divide it up into the colors and then you count up how many colors there are and then you create a graph for it, right? Okay. Now, what if I wanted to know what percentage of students in the class had brown eyes? How would I find that number? What percentage of students in class had brown eyes?
When you total up the amount.
Okay, that's right. So what I'm going to do is I need to know how many total people were in class, which is 17. We have 17 counts here. And then yes, we would take 12 divided by 17. So get your calculators out, start clicking some buttons, and somebody tell me to 3 decimal places, what is the value of 12 divided by 17? Okay, so 0.706.
Yeah.
Okay. Which you said was 70.6%. Very good. All right. Okay. Now, the decimal value that we wrote down right there, that's called a proportional value. All right. So the decimal value of that fraction is the proportional amount. So what proportion of students in the class had brown eyes? That would be 0.706. To find the percent, if you're given the decimal, what do? Move the decimal place 2 places to the right, correct? All right, so when we want to talk about something being proportional or percent, this is what we're looking for. Now, we call that a relative frequency distribution. A relative frequency distribution. So I want you to figure out what is the decimal value, what's the proportional amount for the remaining 4 categories. Okay, so what is the decimal value for blue?
0.117.
Okay, 0.117. Does everybody agree with that?
I would say 0.118.
Yeah.
118, all right, I'll go with that one. We'll round up. So I would have that same value for hazel. How about for gray? What? 0.055?
0.59.
0.05, sorry, I can't hear. All right, 0.059. Do we all agree with that? Yes? Okay, is everybody able to find that fractional value? You take the numerator and divide it by the denominator in your calculator, just like it looks. 1 divided by 17 gives me 0.059. And we call that, again, a relative frequency distribution. Now, if I was looking at the decimal values in that relative frequency column, what should those values all add up to be? The decimal values are going to add up to be 1. The percent values should all add up to be 100. That's right. All right, so if you're looking at the decimal part, that should all add up to be 1, just like the percent values should all add up to be 100%. Okay? All right, now, if you create a distribution like this, which is a table, all right? So when we're looking at this distribution and we have both frequency that we could use as a display or or relative frequency as a display, when would we maybe want one over the other? Why would I want to use a relative frequency distribution? Why would I want to see things given to me in terms of that last column right there? Any thoughts on that? Okay, if I want to graph it, now I could graph it using the frequency, the counts, or I could do the decimals. How about this? Yesterday morning, my 9 a.m. class, they had the same, we did the same thing in that class there. And let's just pretend that in that class, they also had 12 people who had brown eyes. Who had more brown eyes in their class relative to the other? We don't know because I didn't tell you how many total students my 9 o'clock class had, right? So proportionally, the proportion of students in my 9 a.m. class would be the total, right? It's going to change, right? So without knowing that denominator, I can't compare the two to each other, all right? And in fact, I think my 9 a.m. class, I think we had 18, right? So because the denominator is not the same, you're going to come out with a different fractional value. Isn't that right? Yeah?
Yes.
When the denominator is not the same, you have a different fractional value. Okay, so you want to keep this in mind. When you're comparing two things to each other, if they are not the same amount, okay, then you need to change them into their proportional amount or their percentage amount. This drove me crazy at the beginning when they started throwing out COVID numbers, like 2 years ago, right? Where they would start saying that the number of cases, whatever it may be, with the number of cases, they would only give you the number of cases. And they would compare a number of cases from, let's say, New York to Texas or something like that. Okay, well, if I only know the numerator of that, And I don't know out of the denominator, what's the proportion of Texas residents who have COVID? What's the proportion of New York residents who had COVID? Okay, if we don't have the same population, how can I compare who had more cases relative to their population? Okay, so you want to think about those things when you see numbers like that. If you're comparing two things to each other and their denominators are not the same, then you need to put them in terms of decimal values or percentages of each other. Okay. All right, so here is one way for us to display and organize our raw data that we started with. Now, the next way to display it is graphically, okay? And I'm gonna leave this up to you, but intuitively, you probably already know, how can I represent the frequency column, only the frequency column? How can I represent the frequency column in a graph? I want you to draw that for me real fast on your paper. So we're just looking at the frequency column right there. All right, are we about done? Yeah? Okay, so the most common graph to choose for this would be what? What kind of graph did y'all choose? Bar graph, all right? So if I were to draw a bar graph representing the frequency distribution here, I've got my horizontal line, and here I'm going to put the categories. So I have brown, blue, gray, green, and hazel. And then over here on the left-hand side, I would have the scale. And then for the brown, I'm going to draw a rectangle that has a height of what? All right, so I'm coming up here to 12. So I draw a rectangle just like that. Blue, I have a height of 2. Gray, I've got a height of 1. Green, I have 0. Hazel, I have a height of 2. Does your bar graph look something like that? Where the height of the bar represents the frequency of that bar, okay? I could have done the same thing with a relative frequency. It's just a little harder to graph because it's got those decimals in there, all right? But it would actually look the same. The shape of it would look the same. It would be very hard to see too much of a difference between them. Now notice that when we have our bar graph here, right? When we have our bar graph here, one of the advantages to displaying my data in a bar graph is I'm able to compare things to each other. So visually, our eye likes to see the area of something, okay? So when we are constructing our bar graphs, for instance, we may draw them all to different heights, right? Depending on their frequency, but the width of them will be the same, all right? If for some reason I end up with a skinny bar and a fat bar, all right, the overall area of those bars deceives my brain initially, all right, where I might give more weight to the fat bar as opposed to the skinny bar, okay? So that's why they say that all your bars are gonna be the same width, all right? One of the other things that we can get out of a bar graph, again, is if I wanted to compare. Now, I may not have drawn this exactly to scale very well, but if you look at the blue versus the green eye color up there, would you agree that I could say something like the blues are there's twice as many blues as there are greens? According to my picture, right? And, or grays, I mean, not greens, grays.
Like there's 0 greens.
0 green, that's right, I couldn't read my abbreviation there. So I've got twice as many from the blue as I do of the gray, right? Okay, so when you're comparing things like that, that's one of the advantages for our bar graph. Okay, now, did anybody draw anything different? Did you draw something different?
I did, I started with a pie chart.
So you drew a pie chart, right? And then how far did you get into the pie chart? Did you get it completed?
Not scale,
Okay.
but complete.
One of the difficulties in drawing with a pie chart is it's actually a mathematical calculation for the arc and how much of a piece of pie you're going to do. They're a little bit harder to just sketch by hand. Bar graphs are fairly easy if we're just thinking frequency. So those are the only 2 graphs that should have been drawn for qualitative variables. All right, so that's what we're looking at today, specifically qualitative variables, and therefore these are the only 2 ways that we represent those 2 variables. Okay, so let's kind of summarize that information. All right. So the paper that I handed you, right, there is a box up there for you to define a frequency distribution. A frequency distribution lists each category of data and the number of occurrences of each category. It's a table, but we don't have that name in the definition. A frequency distribution is a table summarizing the counts. The other one we defined was a relative frequency distribution. So in a relative frequency distribution, we're looking at either the proportion or the percent of those observations within each category. Okay, now, when we go about calculating it, I always think of this as more like part to whole. Or in other words, in order to calculate the relative frequency, you take the frequency of that category and divide it by the sum of all the categories, part to whole. And then finally, we were talking about bar graphs. So when we look at bar graphs are advantageous over pie charts in that they allow us to compare one category with another, okay? That's typically when you decide you're going to use a bar graph. When I am looking at bar graphs, the order the categories are given in don't make any difference, okay? Now I can organize it in like an ordinal way. Remember, ordinal level of measurement was we were ordering it. I could order my bar graph and then it becomes something special. It's called a Pareto bar graph. But you could order a bar graph in order to identify maybe some characteristics that that you couldn't tell if it was just randomly placed up there. But you don't have to. It's not mandatory. It doesn't mean that your bar graph is incorrect. Okay. So we're talking about frequency and relative frequency distributions, which in our essence tables. We're talking about bar graphs, and then we'll finish the lecture on pie charts. Okay. So what I want you all to do now is, we're gonna follow along. I put one example on your paper right there. It's the online shopping paper or online shopping example. But I need to know that everybody is in Brightspace, right? Is everybody in Brightspace? Okay, because we are going to go together there. And look at some data, but we have to do some things first. All right, so if everybody's in Brightspace, okay, I want you to click on StatCrunch. And then I'm going to click on the website. Okay, is everybody here at this landing page? Shake your heads, yes or no.
Yes.
Okay. Are you getting there to this landing page? Okay. All right. Now, because we are using data in this class, what we're going to do is we are going to join a group, and I usually share the data in the group. That way you can get into StatCrunch and we can both be working with the same data set. So for this one time only, you will come to this part here where it's called groups, and you're going to click on groups. In the search bar up here, I want you to type SK space MCC, hit enter, and you should have my group come up, whatever, MCC statistics spring 22. Did you all have that? Yes? Okay, click on that, click on that link. And in the top left-hand side, you're going to see something that says join the group. Join it. Now, you never have to join the group again. When you go back to StatCrunch under My Groups, this will be the only group that's showing up for you, okay? All right, so is everybody in? Did everybody join the group? So there are actually 3 data sets. These bottom 3 data sets that you see there are going to be the ones that we're going to be dealing with today, okay? So we're going to actually use all 3 of those data sets, okay? The first one that we're going to use is this first one that says Lecture Classwork 2.1. So everybody click on that data set, and you'll see that it opens up in a spreadsheet like over here, window. Everybody see that? Yes? Okay, so this is the question that we are asking. This comes from your paper. If you refer back to the paper that I gave you, it says a random sample of college students were asked what social platform most influences your online shopping. The results are shown. We're going to use StatCrunch to answer some questions down there. And the reason we're doing this together in class is because I want you to record your steps on how you did this in StatCrunch, okay? Okay, now the table that you see on your paper, that's kind of like a table that would show up in your homework question, right? So you would click, there would be a table that shows up, and then you would end up with the option, right, to be able to insert that table into StatCrunch. Does everybody understand what I'm talking about there? Yeah? Okay, well, I'll have to find a homework problem that would be similar to it. But when you get in a homework question and it says, here's the table, right? Because you would be looking at a table similar to what you have on your paper. If you click on that table, there's that little square and a square icon. You'll find it, I know you will. And if you click that link, or if you click that thing, a square and a square, you get the option to copy the table directly into StatCrunch, copy it to the clipboard, or open it in Excel. All right. So basically, what I've done here for us is I have taken that concept, right, of inserting that table that you see there directly into Excel, directly into StatCrunch for us. All right. So this is the table that's similar to what you have on your paper right there. Now, what kind of data in that table is that? Is that considered raw data, or is that considered summarized data? Summarized, right? Because it's already been counted up, right? It's already been summarized how many men responded that they would have chosen Facebook, right? Okay, as opposed to the Disney column over here, that would be considered just flat out data, raw data is what we call it, right? StatCrunch just calls it data, okay? So our table here, we're already given, what kind of a distribution are we given here? Frequency or relative frequency distribution? Frequency distribution, right? The table that we're looking at is already a frequency distribution. What I want to do is I want to calculate the relative frequency distribution for men. Okay, so let's add a column here. I'm going to call it male RFD for relative frequency distribution. So I want to know what proportion of men would have chosen Facebook, or what proportion of men chose Facebook. How do I find that out?
Add up the total and then divide by the number of males,
All right, add up the total what?
number of males.
Add up the total males, okay? Add up the total males. And then for Facebook, we're going to take the 326 and divide it by the total number of males. So quickly for me, how many total males are there? 1,562, that's correct, right? So using that denominator, I need you to find for me the proportional amount for Facebook, Instagram, Snapchat, Twitter, none for males. Okay, everybody should be working on that. And you're just going to add those values in. What was the total? 1,562. So you're just entering these values in just like you would if you were working in Excel, or you're just basically entering these values into each of the cell, into that column that we have now named male RFD. Okay, so we need to make sure that we're going to go ahead and add that to the column in StatCrunch. Do you remember how to find the relative frequency? So what we do, we have 1562 here.
1562.
So it's 326 divided by 1562, right?
Yeah.
Okay. Got the values down? Anybody need any help calculating these values? So this column adds together to give you. So can I so this column here adds. I add. So then for the relative frequency distribution, we're going to take 226 divided by 1562 is you do that for each of the decimals. Okay. Okay, does everybody understand what we're doing? So did everybody come up with 0.209 for the male Facebook relative frequency? Yeah? Okay, so then you should have gotten what, 243, 036, 078, 434. Did everybody get those values when you calculated the relative frequency for each of the categories in males? If not, do you have any questions on how you calculate that? Remember, you're taking the total number of males, which was 1,562, and each time you divide that category for the men by the 1,562. That's the proportion of men who chose each of the categories out of all the men there. Yes? Okay, does everybody have that written into their column there in StatCrunch? Shake your heads, yes or no?
Not yet.
Okay. So what we want to look at now is everybody. So we're going to just focus for just a second on the men, okay? Everybody has this written in? Dan, you got it written in now? Okay. Okay, now, how do I make a bar graph for just the men in StatCrunch? All right, well, you'll find that most of the time when we do commands in StatCrunch, we are really focusing on just these two commands here, stat and graph. Those are the two that we're going to come back to most often. Now, because I want to make a bar graph, that would be under the graph heading, I'm going to choose bar plot. Okay, StatCrunch calls it a bar plot. Now, as soon as I put my mouse over that option, I have the option to choose to create a bar plot with data or with summary. And I'm already dealing with a frequency table that summarized the data, right? So my choice here is to choose the one with summary, because I'm creating a bar plot for the men. Okay, so what did I do so far? To graph a bar graph, I went to graph, plot, and then I chose summary or data, okay? Now, where are the categories for this information? What column are the categories in? Platform, so that's the category, that's the column I choose there. The counts are going to be in males, right? Because I'm creating a frequency bar graph. And so when you look down here, it defaulted to frequency. And then let's just not do anything else. We'll hit compute. All right, does everybody get a bar graph that looks something like this? All right, so that's the same kind of bar graph that we created by hand using the eye color, right? Okay, now if I want to find out some more information about each one of these columns, I can hover my mouse over each one of the columns and it tells me the data that's in there, right? So this is one way for us to be able to graph a bar graph for our categorical data. So I'm going to leave this one up here. And I'm going to graph again. Let's do a relative frequency, okay? Now I've already got the relative frequency data in a column there. So I'm going to go bar plot, summary. The categories stayed in the same column, but the counts are in the column that I created, right? We manually calculated that. And so I don't need to change anything else. I'm just gonna hit compute. Okay. Now I kind of moved things around. It does look a little bit different just because my scale over there for the one we just created, that scale doesn't go all the way up to 100, does it? So or all the way up to 1, so it looks a little different. But this is how we can create that. Okay, so we've got our graphs that we can create. Now, what if, let's look at it a little bit differently. The next question that I have on there says that I want to find out what the relative frequency distribution would be for females, all right? So there's no easy way for us to create a distribution or a table in StatCrunch with the summarized data. If it's already summarized into frequency columns, then there's no easy way for me to get StatCrunch to give me the relative frequency distribution. We had to calculate that by hand, right? There's no command in StatCrunch that is going to tell it to insert that column for me, okay? But there's a workaround, right? So let's try this. I want everybody, first of all, to go to graph, bar plot with summary. Let's do platform for the categories. Let's go back and look at the males one more time. Just the males. That's where my counts are going to be in. But this option down here to change the type, so I can take the information that's already there. I can take the frequency data that's already there, and I can have StatCrunch now calculate for me a relative frequency, okay, which is what we're going to choose. Now, I don't really know what the rest of that is. Don't choose anything besides that, okay? So I've got relative frequency. That's the type of chart I chose. When I hit compute, I have this graph here. Now, again, I can hover my mouse over the Facebook column and notice that it calculated the relative frequency for the Facebook for men, which I can then use to either check my work or I could use it to create a relative frequency column should I need it. All right, did we get our answers right? Hover your mouse over a couple of those and check our work. Did we get them all right? Did we miss one of them? Okay. None is 434. Snapchat is 0.036. Twitter is 0.078. Oh, I have the 0 in the wrong spot. All right. So let's go and now let's create a relative frequency distribution for the females. Let's create a column, only let's do it using StatCrunch's help. So what do I do? Graph, bar plot
With summary.
with summary. Categories are what? Platform. Counts are where? Females. And let's choose a frequency. I mean, the type we want to choose is going to be relative frequency, right? The type of bar graph that I want to look at is a relative frequency bar graph. Compute. And now I can fill that column in by hovering my mouse over each of those bars. Okay, so let's take the time to do that real fast. So we're going to fill these in. okay? So if I'm asked for whatever reason to come up with a relative frequency distribution, which is a table, right? It's a column in a table. I want to know the proportion with which these things are occurring. I can do it by hand. I can also do it using the graph portion of StatCrunch, right? It's calculating it for me. So I could use it to check my work on the homework, okay? I could also use it to save me some time. You are going to be required to know how to do this by hand, so just make sure you know how to find those relative frequency distributions, okay? Now we talked about types of bar graphs that are ordered. And if I came down here, I can change the order. Let's change it to ascending, count ascending, let's do that. Notice that I can just go in there and edit the bar graph I already created, and I just rearranged it so maybe it's going to be easiest for me to see, if I couldn't have told before, which platform were females most likely to use, which platform were females the least likely to use, and it can just order it for me really fast, okay? This is an ordinal way to do it. You don't have to do it. It just maybe lets us compare things fairly easily. Okay, are there any questions on how to create a single bar graph? Where do we go? StatCrunch, where else? Graph, bar plot, and then we're choosing with summary because we already have a frequency table, right? Okay, right? Okay. Now, there are times when I might want to compare. So this is a good example of I want to compare two things to each other. In other words, I want to know what are the habits, the shopping habits of males versus females within each of the categories. All right. So we're going to do a side-by-side graph. And it's a little bit different. So you want to definitely make sure that you write down these commands. Okay. So a side-by-side graph is not an option for me up here under graphs. So for only side-by-side, where I'm comparing two categories to each other, all right, I'm actually going to go to graph and chart. So is everybody writing down that for a side-by-side, these are the commands you're about to use? I go graph, chart, columns. Okay, graph, chart, columns. This is for a side-by-side graph. We're going someplace different. Now, I'm going to come up here and I am going to choose male RFD because those were the relative frequency points that we found, right? That's what we wanted to know. There's something I want to show you though when we're in this cell. All right, did everybody see that when I put my mouse in that box up there, there was like this yellow little instruction line that came up that says to do blah, blah, blah. It tells you to do some stuff. So there are certain keyboard commands that we use in StatCrunch. All right, and I'll remind you how you use these, but what we're looking at is, I want everybody to just click on males. Okay, everybody click on males. Now, hold the control button down on your keyboard, and I want you to click female RFD. Now, it's when you hold control down, it allowed me to select individual components from within a list. All right, so I was able to select only the males at the top and only the female RFD at the bottom using control. Now come back here, click on males one more time. This time I want you to hold the shift button down and select female RFD. When you hold shift down, what did it do? Selected everything in between your two buttons, the two that you selected. All right, so control allows you to select individual components from within a list. Shift selects everything in the list. All right, and that's going to be kind of handy for us when we go to the next chapter. So what we want to do though is we want to select the male and the female RFD, relative frequency distribution, and create a chart for that. I'm going to add in there the row labels, which were the category labels, right? I'm going to add that in. That came from the platform, okay? And the plot. So down here, I have a couple of options. It defaults to a horizontal, but I prefer to see mine vertical. That's just my preference. And so I'm going to choose vertical bars split. And if I hit compute, you now see a side-by-side chart, and I would be able to then compare the shopping experience or the shopping habits of females to males. So if I was looking at Instagram, I think I would be able to say that women are twice as likely, roughly, twice as likely to choose Instagram for a shopping platform than males. Okay. Twitter, men are slightly more likely to use Twitter than females. See how we're comparing two things to each other? Okay, so the default was horizontal. This is considered vertical. So if you chose horizontal, it would just look horizontal, right? Okay, I just like this one. Let me just show you what one of the other options would be. Sometimes you do see graphs that look like this. Let's do a vertical stacked. So in a stacked graph, you're looking at the single category. So if we were to look at Facebook, that single bar, and then you've got to determine what proportion of that bar was for men, what proportion is for women. Okay, I'm not as familiar looking at graphs in this way, so I tend to not use this one, but this is a way for graphs to be displayed in all sorts of things, okay? So you can look at the Instagram one, right? So if women represent the red portion of that bar, and if the whole bar is everybody that chose Instagram, you know, your eye is going to have to tell you how much of that bar is women compared to men. Okay, so that's a stacked. All right, so these are side-by-side graphs. Where did I go for side-by-side? Nope. Oh, yeah.
Graph chart columns.
Graph chart columns. That's right. Very good. Okay. Now, the next thing that we're going to look at, and I apologize, it's not on your paper, but we're going to go ahead and we're going to play with that Disney column that you see right there. Okay. So the Disney column, I already inserted it on your spreadsheet there that you're looking at, but the setup for the problem looks like this. That the table that you see on my screen up here, that table shows the movement of Disney stock for 3 randomly selected trading days. Okay, so for at whatever time during that, okay, they so 30 times, so 10 times a day for 3 days. They recorded at certain times when the stock was up, when the stock was down, and when the stock had no change. What type of a data am I looking at here? Raw data. That's right. That's raw data. Okay. So if we come back to our spreadsheet, the raw data is put into our spreadsheet as a single column. Okay. And now I want to create a frequency and a relative frequency table, because I don't have that right now, do I? I want to summarize this data, and I don't want to go in and tally it up myself. This is why we're using technology, okay? So to create a frequency and relative frequency distribution, we're going to create a table. Write that down. To create a frequency and a relative frequency distribution, you make a table.
Say it again.
For a frequency and a relative frequency distribution, we're making a table. Just like we did at the beginning of class. We made a table to summarize the data. And I'm trying to emphasize that because when I ask you to create a frequency and a relative frequency distribution, the word table never once came in that. And so it's hard to remember that you're supposed to be making a table. Okay. All right. Now, how do I do that in StatCrunch? To make a table in StatCrunch, we're going to go to Stat, Tables, Frequency. To make a table in StatCrunch, we go to Stat, Tables, and Frequency. Okay, so here I am. I want to make a frequency and a relative frequency distribution of Disney. So I'm going to come down here and I'm just going to select my Disney column. And I hope you're seeing that we don't use the where or the group by that keeps coming up in every single one of these pop-ups. Just ignore them, okay? Don't use them. But down here for the statistics, you'll notice that it's already selected for me the frequency and the relative frequency that I want it to find. And I hit compute. Here is the table that you see over here. Now I can insert that table directly into StatCrunch if I want. That was an option on that pop-up screen just a moment ago, or I can just leave it there and I can use that information to answer my questions that I need. I can also copy this information, which you're going to want to know how to do. If I wanted to insert this table, let's say, into a Word document, all right? So I can copy this. If I hit copy, it's going to tell me the directions to use, which is basically just highlighting it, right? So I can highlight everything in here. It's going to tell you, again, we have to use those keyboard commands. Control-C off of your keyboard is copy. Control-V is paste. Control-C is copy. Control-V is paste. That's what you have to do. Okay, so now I have my information here. In a table, right? I have my frequency and my relative frequency distribution for my Disney stocks. And let's go ahead and let's make a pie chart this time. So I'm back to, I've got the Disney column and I want to be able to display that all into a pie chart, which is a type of graph. So I go graph, pie chart. What am I going to choose now? With data. I'm still using the raw data. Okay. So I'm going to select the column that had the Disney information in it. And I don't usually do much else with this. I just leave it alone and hit compute. So you'll see here that I have a pie chart. Okay. And in that pie charts are typically used when we want to compare the, if we have the whole thing and I want to compare like pieces out of the whole, okay? We use bar charts to compare one category to another. We use pie charts to compare parts to whole, okay? So I could come in here, if I just kind of wanted to see overall, I could say that we are, more down than we were up, right? If I'm just looking at this, we had just a little bit of no change throughout those 3 days, right? I can't really get too much of a sense in this, but I can get an idea about the overall picture and how the components maybe played into the overall picture. If I wanted to compare categories to each other, I would choose a bar chart or a bar graph. That's when we use a bar graph. I like pie charts because I think they're pretty, right? I can always get pretty colors with these, but they don't always convey the right type of information that I'm wanting to see. And that is actually what you should be using, not whether it's pretty, right? To be able to convey the information to whoever you're wanting to present it to. How, like you're trying to summarize the information to somebody. And it really just kind of depends on the question that you're trying to ask, or maybe the information you're trying to present. So here is an example of a pie chart. Now, in this pie chart, you see that we have the educational attainment for all of 2017. So these are the categories that you had listed up there, okay? Now, if for whatever reason, the actual number wasn't given on the pie chart, which would not be a good pie chart then, to not have numbers on it, but if only the categories were listed, okay? And let's say I wanted to compare the bachelor's to high school diploma, those shapes of the pie. If I wanted to compare them to each other and there's no number up there, how can I compare them, right? Because those pieces of pie look pretty close to each other, do they not? If they don't have a number on them, they look pretty close to each other. So this pie chart is not a good way for me to be able to compare two categories to each other. The better way to present that information would be in a bar graph so that I could then compare them that way, because the height of the bars is going to tell us who is more than the other, right? Even without numbers, I could still see that, okay? So pie charts are good when we want to know maybe the part to the whole. A good example of that might be, let's say you wanted to go back and you wanted to determine how your expenses, like your spending habits for the previous year were. And maybe you went through and you categorized your spending habits for, utilities, bills, grocery shopping, entertainment, and those kind of aspects, right? If you wanted to look at the whole picture of your expenses, that's when you would use a pie graph to be able to get a sense of that, okay? All right, what types of variables were these that we're using? What type of variable is it that uses both a pie chart and a bar graph?
Quantitative.
Qualitative, right? Qualitative. Categorical, yeah? Categorical data, okay? Because we can put it into categories, right? Bar graphs and pie charts. We use categorical or qualitative data for these types of graphs, these graphical displays. Are there questions on that? All right, so what you're going to finish doing is on your worksheet there, on the back of your worksheet, you have problems 2 through 6. Now, we're no longer using that data set that I gave you. So for question number 2 on your problem, you're going to use the tornado data set that's listed there. And for question number 6, you're going to use the student survey for your data. All right, which is why I've shared them with you. So for question 2, you're using the tornado data. For question 6, you use the survey. Now you don't have to turn this information into me. This is just you practicing in class right now, okay? But question number 6, you will turn into me. Everybody hear that? Only question number 6 you will turn into me when you come back to class on Thursday, all right? It counts for extra credit on your quiz, okay? And in question number 6, when you look at your paper right there, question number 6 asks you to choose a qualitative variable from our class survey, whatever you want it to be, okay? Choose a qualitative variable from the class survey, create a frequency and a relative frequency distribution for that variable, create both a pie and a bar graph for that variable, and then go in and tell me which graph would be more appropriate and why. Okay, which graph would be more appropriate and why? Because one Pie chart would be more appropriate for some things, bar graph would be more appropriate for others. Just be able to support your answers. All right, you can copy and paste these graphs into a Word document. You can copy and paste the tables into a Word document, or you can sketch it. Either way. All right. All right, so the remainder of the class, that's what you're going to be doing. You're going to be working on this. And if you have questions, now is the time to ask about some of this. Okay, all right.